So section 1.6 has applications of linear systems. How many remember balancing equations in chemistry? How many remember doing that? Okay, Natalie knows. Sharani, okay. Yeah, well, and yeah, Justin knows. So of course the trick was, you know, finding the right integers, and you had to count the atoms and all that. And you're going to find linear algebra is very helpful for balancing chemical equations. You're not going to have to go through that pain anymore. All right, so let me give you a moment to copy this down, this example. Okay, so we want to balance the chemical equation, and let's see, what are we balancing here? We're taking what's C sub, well, what's O2 stand for? O sub 2. I hope you know. Okay, oxygen, and then this is C3 sub H. C3H8 is propane. Good, good. O2 is oxygen. We're going to combine those molecules together to produce what? What's it going to produce? What's CO2? CO2 is carbon dioxide, good. And H2O is, of course, water. Okay, so what if we could represent each one of these molecules well, each one of these molecules in the reaction by a vector? Okay, what if we could do that? Let's see how that would work. All right, so what I'm going to do, well, first of all, we need to find, to balance the equation, we need to find x1, x2, x2, x3, x4, those values, such that x1 times propane, some number of propane molecules, plus x2, some number of oxygen molecules, will produce a certain amount of carbon dioxide and a certain amount of H2O, simply put. Okay, I mean, that's what we're trying to do. We're trying to find those coefficients that will balance this chemical equation. And so what we can do is, if we were to denote the number of atoms per molecule, okay, we can represent propane, oxygen, carbon dioxide, and H2O, water, with these vectors. Okay, so take a moment to think about that. I mean, certainly these vectors, each of these four vectors is unique to the molecule it represents. So in the first spot, we're reserving the first spot for what atom? What type of atom is used for the first? I mean, these vectors are each 3 by 1 vectors. The first vector represents what? I mean, the first component of the vector represents what? Good, Justin. Carbon. Good, Eleanor. What about the second component of the vector? It represents what atom? Well, let's see. Hold on. Hydrogen. Hydrogen. Right, right. And then the third vector is going to represent the third component in the vector would represent the number of what atoms? The number of oxygen. Good, Eleni. Good, Eleanor. So are we okay with these four vectors here? Are there any questions? And why each of these vectors represents its corresponding molecule? All right, well, if you're good with that, then balancing, thank you, Eleanor, then balancing the equation simply means find x1, x2, x3, and x4 to solve this vector equation. So you've taken this problem of balancing a chemical equation and you've rewritten it as a linear algebra problem where you have to balance a vector equation. Are there any questions on the vector equation? Okay, may I? So now that we have this vector equation, what can we get from the vector equation? What will the vector equation yield? It will yield a blank of equations. It will yield a system of equations. That's right, Hung. That's right. So let's see. Now, of course, in order to get the system of equations, you're going to have to take this vector here and bring it over to the left side, and you're going to have to take this vector here and also bring that over to the to the left side. So on the right side of this, I mean, we could rewrite this vector equation so that on the right side of the vector equation we have all zeros. In other words, we would have a homogeneous equation. So let me go to the next page and show you the system of equations then that the vector equation produces. This is the system. Are there any questions on how we got that system of equations? So of course I took the two vectors on the right side of that vector equation and I brought them over to the left. That's how I get, negatives, negative values there, right? And then the right-hand side of the vector equation is the zero vector. Now we take that system of equations and express it, excuse me, as an augmented matrix. And I want to get that matrix in reduced echelon form. Okay. Let me just see here, one moment. Are there any questions so far? May I move to the next page? Let me know when you're ready. Okay. Benjamin's good. Okay, Andres is good. Wonderful. Okay, thank you, Lewis. All right, so we'll go to the next page. And actually, I think when I scanned it, I missed a page, but it's okay. I'll fix it right here. We're not going to go to the next page. We're going to stay on this page, okay? We're going to stay on this page. So what we're going to do here, is, hold on. We're going to use MATLAB. We're going to use MATLAB to reduce this matrix down into reduced echelon form. So we're going to use MATLAB to row reduce our matrix. Use MATLAB to row reduce our augmented matrix. Okay. All right. So what I'm going to do, I'm going to go into. So MATLAB, you want for the problems in section 1.6, you may use MATLAB to help you do row reduction because you're going to have big systems of equations. So for section 1.6, you know, you may use MATLAB to help you. Okay. So let me go into MATLAB here. What we have to do, we have to let MATLAB do the row reduction and get that matrix in reduced echelon form, and that's what we're gonna put the result down here. Okay, so let me go in to MATLAB here. Hold on, class. Remember, in Blackboard, hold on, it's got to be here. Yeah, in Blackboard, you have under the course information, if you go to course orientation, there are instructions on how to install MATLAB for free. So you can upload it onto your computer's laptop or your laptop. I think everybody gets one copy of it. But you know, it's your personal copy, and you don't have to pay. It's free. How many have uploaded MATLAB already? Has anybody done that yet? All right, excellent, excellent, wonderful. And you want to do that for Thursday's class. Certainly, you want to do that for Thursday or Wednesday's class. All right, so let me go ahead here and show you what I'm going to do here. So I'm going to type a matrix A, and I'm going to type in the rows. And then rows are separated by semicolons. Okay. Rows are separated by semicolons. And, you know, the zeros, I'm not worried about the negatives on the zeros. Let me know if you have any questions. Hold on, let me, one moment. Andres, not that I know of. To my knowledge, entering in the matrices, you enter it by rows. That's at least the default. Okay, so now there's my matrix A. Okay, and what I'm going to do is I'm going to do RREF of the matrix A. That means take the matrix A and put it in reduced row echelon form. Okay, you notice the matrix A is stored up here. It's stored up here. Okay, in the workspace. So, all right, I hit that, and I get it in reduced form. Hold on here. There was a question. Now we might go over a few minutes. This is going to be on the recording, but if you can stay maybe an extra 5 minutes, I can finish up the example. I'd be grateful. If you have to go, I understand, but try to stay if you can. Hold on, there's a question here. All right, yeah, Benjamin, I hear what Benjamin's saying there. You know, in the chat window, but you know, this works. So, okay, now here's the thing. You notice that that when I did the row reduction, of course, I have these decimals. If I use the command called format RAT, that means give me fractions. That means MATLAB, I want you to give me fractions. And so if I then just use the arrow up key, I can bring that command back, two commands back, and hit it again. And now I have the matrix in reduced echelon form with fractions. And fractions are good because MATLAB, I mean my MATLAB, you have to read the instructions. You have to read it carefully. Sometimes I want decimals, sometimes I want fractions, but you know, fractions are, if they don't say anything, fractions are usually safe, right? Are there any questions on this? Okay, then I'm going to go back to the whiteboard here, or back to the, hold on, the thing here. I'll stop sharing here. By the way, yeah, okay. There are different formats that you can use in MATLAB. So you can do like format short. Well, there are different format commands. If you want to get it back as reals, there's. I'll let you investigate that because I'm a little pressed for time. But I think if we do format like short or format, forgive me, NUM. I'm trying to think of the command. No. Format short. I'm trying to see format short. See, I can't see it because can't see what I'm typing because there's a thing here that's blocking it. Format short. Okay, and now if if I do that and bring back RF, now it brings the decimals back. Okay, so, okay, great. So I'm glad I was able to get that in for our thing. Okay, so let me go back to the thing now. Hold on here. Okay, so now, okay. So now, using MATLAB, this reduces just putting that in for the augmented matrix. Okay, so let me ask you, is there going to be, we have three different equations, 4 variables. What's that tell you about one of the variables? One of the variables is going to have to be free variable. Excellent, Eleanor. That's right, Nafoni. And of course, now we can figure out what okay, so x4 is going to be free, and then we can figure out x3, the value x3, x2, and x1 right from our reduced row echelon form matrix. Okay, so I want to go and get to the last page where the solution is, where the final page is. But are we okay with this? May I move on? Are there any questions? Okay, thank you, Nafani. Thank you, Ariana. Let me move on then. So then row reduction is going to lead to this solution here. X4 was free. X3 is 3/4 X4. X2 is 5/4 X4. And X1 is 1/4 X4. So there are many answers to the values for X1, X2, X3, and X4. But what do you remember about the coefficients in the chemical equation? They have to be what? Coefficients have to be what? The coefficients need to be integers. That's right, Benjamin. They have to be whole numbers. That's right, Hung. And in my math lab, they want the whole numbers to be like the smallest whole numbers. Okay, so since you have in X1, X2, and X3, you have a fourth, 5/4, 3/4. It makes sense to let X4 be 4. And if X4 equals 4, X1 would be 1, X2 would be 5, and X3 would be 3. And so then in this case, this is the balancing of your equation. 1 molecule of propane plus 5 molecules of oxygen combine that, and you will yield, the reaction will yield 3 molecules of carbon dioxide and 4 molecules of H2O. Okay, and you have balanced the chemical equation. And you didn't have to go through all that, guessing in your mind about, trying out different integers. I mean, how many kind of love this? How many are taking chemistry and love this for chemistry? Or how many would have liked to have known it when they took chemistry? Okay, Justin, Eleanor, Nafani. Yeah, there you go. All right, Hung, there you go. Are there any questions on this? All right, well, section 1.6 deals with, there are multiple applications. And we did balancing a chemical equation, but there are other important applications as well. And we will talk about those, discuss those on Wednesday's class. So if there are no other questions, hold on here, let me see here. If there are no other questions, I'll stop the recording.